printed right here, do you remember how that works?
Yep.
You do need to go over?
No, we remember.
Okay.
Like that.
Okay, this is my subnet mask portion on the top, this is my first requirement that's on the bottom. I just like to have the X's there because it's easy for me to use the X's for counting. That's all I need it for. So, well, the first thing I want to do is calculate the number of host bits that I need for each one of these. The 70, the 25, the 10, and then the 16. WAN is always going to be two host connections. The WAN is, I need an IP address here, and I need an IP address here. Boy, is it one.
I don't know exactly what's wrong with it. It said error opening TFTP with the...
I know it's not there.
Alright.
Okay, now, who can remember the process, the mechanical, not the mathematical process, but the mechanical process we use to figure the number of bits we need to cover 70 bits? And that would be, are you raising your hand up there?
I am.
Over here? Okay.
You want to go on the bottom of the chart
Okay.
to a number higher than 70, 128, and now count backwards from 64, 1, 2, 3, 4, 5, 6, 7, 7,
I mean, 7 bits, 7 host bits, right?
and that,
Okay. And if I want to prove that, then I would take 2 to the 7 minus, and then you do minus 2. 2 to the 7 minus 2. That's 2 times 2 times 2, 7 times. So it's lazy, so we'll do it on the calculator. So I'll just tell you, because I already know that. Looking it up here, it's 64. Okay. This is 2 to the 7th right here, which is 64. Right. 2 to the 4th is 8. 2 to the 6th is 32. I can just pull off in my table here. So the number of hosts, let's see, 121. I'm sorry, 2 to the 7th is 128. And copy. 2 to the 7th minus 2 would be 126 that I can take care of. So more than enough, more than cover my requirements. How many bits do I need? There's 25 hosts. 25 hosts. 32.
32.
1, 2, 3, 4, 5. I'm trying to illustrate that this is very easy, folks. 10. Okay. Up to 16, and 1, 2, 3, 4. And then 2, this is the only place where there's a little bit of a wrinkle here.
1.
Because I need a number bigger than my requirement. My requirement is 2. I'm going to go to 4. 2 is not bigger than requirement. 4 is bigger than requirement. And then go back 1, 2,
3.
Okay, everybody got that? Really brain dead simple. Brain dead simple if you do it this way. So, I might not have a chart that looks exactly like this, but basically, if you don't see that chart exactly like that on your time, you need to scratch it up so you can get the stuff on it. And we'll have all of the stuff available to you so you don't have to remember all of these columns. You can look it up on Angel pretty quickly. So if I'm using 7 host bits, how many bits do I have left over for use for the network?
1,
How do they get that?
because there's only 8 bits.
Okay, so 8 minus 7 is equal to 1. What's this number right here?
3, 4, 6, 6, 6.
So this, all we have to do is
So satanic.
to be able to prove it to the number 8. So if this is 7, 8 minus 7 is equal to 1. If this is 5, 5 minus 8 minus 5 is equal to 2, etc., etc. Again, very, very easy. What about math? Again, this is a simple lookup business. This is not mathematical calculations. I don't have to worry about add additions or anything else like that. How do I calculate what the math should be and the network address is going to be known?
254.
Top of the chart.
Okay?
Start from the left and count right. So if there's 1, count 1.
And I got 128. Okay?
Oh,
I'm not
okay.
going to do the whole thing. This is just
Oh,
the
it's not.
last text. So it's
You need
255, 255, 255, dot 128. So 3 network bits would be, the math would be what?
224.
224. 1,
Perfect.
2, 3,
Okay.
224. Brain dead easy. What's the next one? 240.
240.
What's the next one down here? 252. And 252. And then 253. So again, one more time, my math is 255, 255, 255, for example, 224. So we're looking at the last step here. This is just keeping, we're not having to do it. Now, the subnet, my very first one is 192, I'm going to put the whole thing here, the first one, 192, 168, I'm sorry, it was 100, 100.0. The very first address, because it was the address given to me, that it's God up in the sky, and God IP address. That's the IP God. What I want to do is figure out what the next one is going to be. Just the tedious amount of background here so you get a better understanding of what's happening. It's self-coupled, you have to understand, but it's not absolutely necessary. The NASP defines the extent of my subnet. If I put in a mask of 128, I'm defining how many numbers are in my subnet. And the way I calculated that is by taking 256 and subtracting 128 from it, like we just do the process that I do. So if I take 256, which is constant, and I subtract 128 from it, what is my number?
128.
So it says that there are going to be 128 numbers in my range, and that particular range by IP address. I can also do that by going over here and saying, if the map is 128, then my range is 128. So the very first subnet is .0 like I have up there, and I'm going to go 128 numbers from .0. 128 numbers from .0 would leave me at what number?
128.
Well, 129 number. So I gotta count 0. Okay, so 0 plus 0 being the first number. If I go 128 numbers, what's my last number?
127.
What's the
127.
first number in the next range?
128.
So if I go up here and I say my mask is 128, I know my increment is 128, therefore I can take the base number and add 128 to it and come up with my next, or the beginning of my next one. We all see that?
Yeah.
Okay. Now if I want to do the same thing here, 224, if I take 256 and subtract 224 from it, and we get 32. It says that the range of my numbers is 32 numbers. If I take the base of 128 and I add 32 to it, I'm going to get 194, right? 32, 160, what is it? 160. So from 0 to 127, which is the number prior to this one, like this, is 128 numbers. From 128 to 159 is 32 numbers. 224, right, 32 numbers. Now we're going to take this one, 240, and this one is going to be 16 numbers. 16 numbers. Okay, so 256 less 240 is equal to 16. 240 is 16 right here. 160 plus 16 is equal to 176. So between 160 and 175 is 16 numbers. So including 160, 161, 162, 163, etc., up to 175.